From lesson 6C, this is review 1 and review 2. We are undoing multiply, divide, and add, subtract to our variable x that we're solving for. So take a screenshot and try them on your own and then follow along with me. Number 1, x minus t equals 37. I want to get x alone. T is attached by subtraction, and according to PEMDAS, when we solve, we undo PEMDAS, and we undo subtraction first. So its partner is addition. I'm going to add the t to the other side of the equal sign, and I'm done. X equals 37 plus t. Number 2, 2x equals 37. I want to solve for x. 2 is attached by multiplication. Move it by division to the other side of the equal sign, and I'm done. X equals 37 over 2. Now let's put it all together. We want to solve for x. I have something attached by subtraction, and I have something attached by multiplication. I undo subtraction first by adding it to the other side of the equal sign. Now I want to get x alone. 2 is attached by multiplication. Move it by division to the other side of the equal sign, and I'm done. X is equal to 37 plus t all over 2. Number 4, 5x minus h equals 12. I want to solve for x. And h is attached by subtraction, 5 is attached by multiplication. I undo subtraction first. I add it to the other side of the equal sign. Now I want to get x alone. 5 is attached by multiplication, move it by division to the other side of the equal sign. X is alone, and it's equal to 12 plus h all over 5. Number 5, 5x minus h equals 12. I want to get x alone. I'm going to undo subtraction first by adding it to the other side of the equal sign. 5 is attached for multiplication. Move it by division to the other side of the equal sign. I have now solved for x in terms of h. Number 6, m is equal to m plus 25x. I want to solve for x. There's something attached to it by addition, and there's something attached to it by multiplication. According to PEMDAS, I undo addition first, so I have to subtract it. And I have no room but up here. Not so pretty. Now I want to get x alone. 25 is attached by multiplication. I have to move it to the entire other side by division. And I'm going to write that equal sign there, okay? So now I've got to clean this up. Whoops, I forgot to cross it out. Cross it out after you've moved it. Try to cross it out after you've moved it, because if you cross it out before you move it, sometimes your memory forgets what it was exactly. Okay. Then when you come across and cross it out, it's like you're checking yourself. M minus m is equal to 0 over 25. 0 over 25 equals 0. I have solved for x in terms of m, and it's equal to 0. Number 7, 2x minus p equals p. I want to solve for x. So this p is attached by subtraction. I'll move it by addition to the other side of the equal sign. Keep your eye on the prize. I want to get x alone. 2 is attached by multiplication. Move it by division to the other side of the equal sign. And I'm getting x equals p plus p over 2. We haven't gone through this yet, and I do a whole topic section on variables, adding like terms, but I'm going to do it for you here so you can kind of get an idea of it. P plus P. I have 1P plus 1P. That is equal to 2 P's, and it's over 2. This 2 and this 2 go away, and my final answer is P. Number 8, 34 equals AX minus D. I want to get x alone. D is attached by subtraction to this side. Move it by addition to the other side of the equal sign. I still want to get x alone because that's what solve means. A is attached by multiplication. Move it by division to the other side of the equal sign. And I'm done. X is alone, and it's equal to D plus 34 all over A. Number 9, M plus KX equals P. I want to solve for x, which means get it alone. M is actually attached by addition. Move it by subtraction to the other side of the equal sign. Now I still want to get x alone. K is attached by multiplication. Move it by division to the other side of the equal sign. And I'm done. X is equal to P minus M all over K. Here's review 2 for lesson 6C, variables only, where we're solving for x by moving things that are attached by addition or subtraction and multiplication. Take a screenshot and follow along with me. Number 1. X plus star equals 32. I want to get x alone. Star is attached by addition. Move it by subtraction to the other side of the equal sign. And x is alone. It's 32 minus star. Number 2, 14x equals 32. I want to get x alone. 14 is attached by multiplication. Move it by division to the other side of the equal sign. I can reduce that. I can write 32 as 16 times 2. I can write 14 as 7 times 2. 2 over 2 reduces to 1. So these reduce to 1, and I'm left with 16 over 7 equals x. Number 3, 32 equals 14x plus star. So you might see this is putting numbers 1 and number 2 together. So I want to get x alone. 14 is attached by multiplication, star is attached by addition. To undo addition, I minus it to the other side of the equal sign. Wish I had left more room. Now I want to get x alone. 14 is attached by multiplication, move it by division to the other side of the equal sign. And I'm done. 32 minus star over 14 equals x. Can I reduce this 32 and this 14? I cannot, because see this star up here? I would have to be able to take a 2 out of everything on top to take a 2 out of the bottom. So what I like to think in my head is I always count on PEMDAS. Add, subtract, go together. Multiply, divide, go together. Add and subtract can move through each other. Multiply and divide can move through each other. This is a subtraction and this is a division. They don't move through each other. I'll work on this a lot more. Number 4, 10x minus p equals 198. I want to solve for x, which means get it alone. P is attached by subtraction, move it by addition to the other side of the equal sign. Now keep your eye on the prize. Don't look at anything over here happening, just your goal. 10 is attached by multiplication, move it by division to the other side of the equal sign, and you're done. X is equal to 198 plus p all over 10. Can I reduce the 198 and the 10? No, because 198 is attached by addition to p, and addition does not move through division. Number 5, 10x plus p equals 46. I want to solve for x. So I'm going to undo this addition by subtraction to the other side of the equal sign. Now I want to get x alone. 10 is attached by multiplication, move it by division to the other side of the equal sign, and I'm done. X is equal to 46 minus p over 10. Number 6, 27 equals 2/5 x minus r. I want to solve for x. R is attached by subtraction, move it by addition to the other side of the equal sign. 2/5 is attached to x by multiplication, move it by division to the other side of the equal sign. I'm done, x is alone. I can handle this complex fraction for you. I'm going to rewrite it down here. All over 2/5. This is the division bar. Flip the bottom over, put it at the top, 5 over 2. So what I get here is 5 times r plus 27, all over 2 equals x. That's done. Number 7, negative 7 plus 2x equals L. I want to get x alone. There's something attached by multiplication and something attached by addition. So I'm going to move this negative 7 over by subtraction, minus negative 7. I'm not going to reduce till I get my x alone. I just keep my eye on the prize because I don't want to stop the flow of my problem. And here comes Trudy. Okay, 2 is attached to x by multiplication. Move it by division to the other side of the equal sign. And I'm done. But when I have a minus, a negative, that can go together to make a plus sign. So I can rewrite this as L plus 7 all over 2. This doesn't reduce anymore. I'm going to do something just to show you that I can do it. I can put the denominator under every term on top. Terms are separated by plus, minus, or equal signs. So I can write this as L over 2 plus 7 over 2. And I'll do that once in a while just to show you I can do that. But the 2 can't only go into the L or only into the 7. It has to go into both. Number 8, 2 2/3 equals 2/3 x minus z. Keep your eye on the prize. I want to get x alone. Z is attached by subtraction. I'll move it by addition to the other side of the equal sign. Now I want to get x alone. 2/3 is attached by multiplication. Move it by division to the other side of the equal sign. Now I am going to clean this up for you even though I'm all done. So I can, first I'm going to write it like this so that I have room. And this is division. So complex fraction, flip the bottom over and put it at the top. And that turns into multiplication. But this fraction bar makes everything above it a package. So I can go 3 times z plus 2 2/3 all over 2. And that answer looks good to me. I can go just a wee bit further if you'd like. I can distribute that top. So I'm going to get 3z plus 3 times 2 2/3 all over 2. And I can even now split it up if you'd like. And I'm going to get 3z over 2 plus 3 times 2 2/3 all over 2. I'm still not loving the look of this. 2 2/3, I can turn it into an improper fraction. 2 times 3 is 6, plus 2 is 8. So I'm getting 8/3. So I'm going to come down here. So 3 times 8/3 would be, the 3 and the 3 go away, and I'm getting 8. So I could rewrite this as 3z over 2 plus 8 over 2, which is equal to 3z over 2 plus 4. Whew! Now really, I was already done here. I was done. I'd solve for x. It was alone. This is just cleaning up all the fractions and kind of teaching you something if you're interested. Number 9, a minus b plus 6x equals c. Keep your eye on the prize. I want to solve for x. There are things attached to it by addition, subtraction, and multiplication. So I'm going to move each piece as I get to it. And I have to undo subtraction first. So I'm going to take that b and add it. It's gone. I'm going to take this a, which is actually attached by addition, subtract it. That's all done. Now I want to get x alone. Doesn't this look so easy when we're almost done? 6 is attached by multiplication, move it by division to the entire other side of the equal sign, and we're done. Number 10, px minus 1 equals q. I want to solve for x. There's something attached by multiplication. There's something attached by subtraction. Undo subtraction first. By its partner, addition. Almost done. P is attached to x by multiplication, move it by division to the other side of the equal sign, and I'm done. X is equal to q plus p over 1. I'm going to just split that up for you again. Remember, I can put each top over the whole entire denominator. So I can get q over p plus 1 over p. I go through this a lot in fractions. Thanks for being here.